Swayam Prabha. Digital India. Educated India.
Welcome back, dear learners, to this NPTEL course on low cost building materials and techniques. My name is Dr. Vishal Chettry and I am working as an assistant professor in the Department of Architecture, Planning and Design at IIT BHU Varanasi. So in this lecture we will focus on vernacular architectural style, specifically talking about climatic zones such as hot and dry, composite and warm and humid climatic region. So the architectural style that are prevalent in these regions, which can also the learnings from this PPT will help you in minimizing the cost of the construction by following the passive features or the low cost features that are adopted in the vernacular architectural style. So that is why we have included this in this particular subject, and to make you aware of vernacular architectural style that are prevalent in this region and how they can be useful in designing a low cost building. The content of this presentation will include climate responsive vernacular design in hot and humid climatic region. It will also include design strategies for hot and dry climate, design strategies for composite climate, also for warm and humid climatic region. Then we will try to identify thermal comfort strategies in vernacular buildings that are seen in all these regions and understand how these can be referred for modern low cost housing. At the end we will try to conclude the presentation with the overall learnings, some wrap up activities, and then the topics that are covered in the next presentation, and along with that some resources will be shared with you so that you can explore more about these topics. To give you a recap of what we had covered in the previous presentation, we understood the concept of vernacular architecture as climate responsive and locally evolved building practices. We also learned how climate responsive design principles guide the building form, orientation and material selection. We also explored the different design strategies for cold and cloudy climatic region, which focuses on heat retention and compact planning. We examined design strategies for cold and sunny climatic region and also understood the utilization of solar gain and thermal mass. So how these can be maximized to enhance the thermal comfort in cold and sunny climatic region and as well as in cold and cloudy climatic regions. All these were covered. We also analyzed moderate climate strategies that are used in moderate climatic zones, which balances ventilation, shading and thermal comfort. Overall, we try to understand the importance of local material and traditional techniques in ensuring that the cost of the construction is minimized and the sustainability is enhanced for all these kind of projects. So now let us now that we have already focused on the previous presentation, specifically pertaining to climatic regions such as cold and cloudy, cold and sunny, and as well as in moderate climatic region. Now let us understand about hot and humid climatic regions. So climate responsive vernacular design in hot and humid climate refers to the traditional practices that are specifically adapted to high temperature like 35 to 45 degrees Celsius. So sometimes the temperature also reaches to 45 in warm and humid. Generally, on an average, it doesn't exceed 40 or 41 degrees Celsius, but in certain cases there have been cases where the temperature has reached to 45 degrees Celsius also, but that is very rare. And but overall the main concern over here is not the high temperature, the concern is high level of humidity, that is somewhere between 70 to 90%. So that is a huge number to give you an idea. So anyone who is residing in this kind of humid condition, it is quite discomfort, like uncomfortable for anyone to inhabit in these locations because of high humidity. Because of high humidity, what happens is there is lot of sweating that happens, and then you will start feeling discomfort in a space if it is not well designed. Also, there are heavy rainfall conditions in these areas which aims to maximize like all these issues. So that is where the level of comfort through ventilation, shading and moisture control is to be undertaken through design interventions. So primary goal in hot and humid climate region is to remove heat and humidity. So unlike hot and dry climatic region, the main aim here is to remove excess heat and moisture or humidity that is prevalent in this climatic region. So high humidity can only be removed if there is better or strong cross ventilation in a particular space. For example, if in an enclosure, if the air is intact, if the same air with high humidity is allowed to remain in its place without allowing it to escape through the space, then the discomfort level rises. And in similar conditions, if you have openings in both the opposite walls and then the air is allowed to pass from this space and there is no stagnant air that is present, then with that flowing breeze you will start feeling comfortable gradually. So that is what has to be understood. High humidity also reduces the body's ability to cool through evaporation, because already there is so much of moisture in the atmosphere that the moisture from our body is not it doesn't get off very easily. So that is a major issue over here. Maximizing air movement. So the building has to be designed in such a way, or the house or any space has to be designed such a way that it maximizes air movement. Buildings are designed to enhance cross ventilation, achieving indoor air speeds of about 0.5 to 2 meter per second. So that is why fans are very effective in these regions. So such example, fans as well as cooler doesn't work over here, because there is already so much of humidity in air. The lightweight construction materials like bamboo, timber and thatch are used because they do not store heat, helping interiors cool quickly after sunset. So if you remember the map of India that I had shown you about different climatic region, so warm and humid or hot and humid is mostly seen along the coastal belt and in the northeast region. So all these coastal areas generally use such lightweight material. So in northeast it is bamboo, and in other regions it is wetland daub wall, or it is those laterite blocks that are available, because these are perforous in nature, due to the perforations in the material, it doesn't stores heat in the within the material. So it allows heat to dissipate very easily from the material. So then also the elevated structures like stilt houses, buildings are raised from 1 to 3 meter above ground to prevent flooding and allow air circulation below, reducing dampness. So these are practices that are also followed in hot and humid climatic region. Shading and vegetation like trees, verandas and deep overhangs reduce solar heat gain by 30 to 60% and create cooler microclimates. So most of the houses that we see in Goa, Kerala, they have huge wide verandas, and the overhangs are also very deep because of many reasons. Like there in the coastal regions, so there are strong winds that come with the rain. So to stop the entry of rain inside or rainwater inside the structure along with the wind, so the overhangs are designed in such a way that it is leveled down, is quite at low level compared to what we see in other areas. So in that way it protects the plinth or the verandas, as well as it protects the sunlight to enter the structure. Then the other is moisture resistant design, that is elevated plinth, which like use of breathable material and elevated plinth, helping prevent fungal growth, dampness and decay. So these are some of the design strategies that are very much seen or very common in hot and humid climatic region. So the design strategies, if we specifically see for hot and dry climatic region, it is compact settlement planning that is followed, because the more you scatter, the solar heat gain also increases. So that is why compact planning is generally preferred in hot and dry climatic region. So if you remember any buildings from Rajasthan or from Gujarat, you will find those typical houses where it is very compact in nature, it is less opened as we see in warm and humid and other climatic regions. So buildings are closely spaced, so they sometimes common wall is present between the two buildings, and there is very narrow streets. Because of that, the buildings actually shade each other, so there is mutual shading of the buildings, and with that the spaces doesn't are not exposed to sunlight, direct sunlight. So thick walls with high thermal mass are built, so using mud or stone walls around 300 to 600 mm thick are used in these climatic regions. So they delay the heat transfer by around 8 to 10 hours in such climatic region. Small and recessed windows, so over there the windows are very small, so window to wall ratio is usually between 10 to 15% to minimize solar gain. So all those bhunga houses that we see in Gujarat and in some parts of Rajasthan, so these houses are actually circular in shape, as well as the openings that are present in the houses are very small, and at times they are at upper levels, because the tendency of hot air to escape is always through upper levels, because it doesn't settle at ground, it is somewhere at the top level. So that is why having ventilators in these regions are very much effective. Also similarly in warm and humid climate region, where we find these ventilators are very common in warm and humid climatic region, because we want hot air to escape from the room as soon as possible and as much as possible. And since we know that the tendency of hot air is that it always is present at the upper level of the space, so that is why if we have ventilators, so the air escapes very easily from these openings that they are at the top level. So the ventilators are designed quite near to the roof in these regions. Then small and recessed windows for hot and dry. Along with that, some jali that we have seen mostly in buildings that are built in Jaipur. We have seen lot of jali that are being seen over there. The famous among all of these is the Hawa Mahal that is there in Jaipur. So the entire facade is designed with jalis that are present. So these jali, what it does is, the air when it comes in contact with these openings, due to its contact with the material, the air temperature is actually reduced, and further due to the pressure of this hot air directly coming into the contact of the material, the cooling of air happens because of that, and then inside these jali we find the temperature to be lesser because of this reason over there. So that is why jali is very much preferred for other reason also, like it doesn't allow direct sunlight to enter the space. With jali you block the entry of direct sunlight into the space. So that is also the other reason why jali is very prevalent in hot and dry climatic region. Then the other factor or the other design pattern is the prevalence of courtyard planning. So courtyards are also created which with shaded microclimate and can lower indoor temperature by 2 to 4 degrees Celsius. Also light colored exterior surfaces, like light colors reflect solar radiation and reduces heat absorption. So that is why in Jodhpur or somewhere in either in Jodhpur or Jaisalmer there is a kind of entire locality which is looks like blue in color. So these blue houses in those regions are mostly designed because of the material that is used, indigo as a material. Since it is very light in color, so it doesn't allow sunlight to absorb. It reflects sunlight because of the color of the material. Wind catchers and ventilation shaft. So traditional wind towers can increase indoor air velocity by 0.5 to 1.5 meter per second. So these are some elements that we have seen. So the torrent energy building that is there in Rajasthan has actually these elements in their design. So you can explore that building and understand how wind catchers and ventilation shafts can be helpful in enhancing the thermal comfort of the region. So the case study for hot and dry climatic region is the traditional houses of Jaisalmer, where you will find very less openings and the prevalence of jali in the opening. So urban form is and compact fabric is there. The city has dense compact planning with narrow streets, lanes, reducing solar exposure and creating shaded urban spaces. The material that they use is yellow sandstone. Locally available sandstones of thickness around 450 to 600 mm is provided, which has high thermal mass and maintains indoor temperature somewhere comparatively 5 to 7 degrees Celsius lower than the outside. Small openings with jali work that is present. Intricately carved stone jalis filter sunlight and allows ventilation while reducing glare and heat gain in the structure. Courtyard houses, which are of Haveli typology. Houses are organized around courtyards that enhance airflow and create cooler internal environment. So here the courtyards that are present are, since the structure is not just ground only, it doesn't have only ground floor or G+1, it is G+2 and G+3, and because of the ratio of the height and with the width of the courtyard, it is designed in such a way that in most of the time these courtyards are shaded and very there are very less exposure of this courtyard with sunlight, and all the hot air that is present in these rooms surrounding to the courtyards allows these courtyards actually allow this hot air to escape from the courtyard. So that is why courtyards are also preferred in such Haveli houses, and these are some type of internal courtyards which are not directly exposed to the outer areas. Flat roofs with insulation layers. Roofs use mud or lime layers at the top of 100 to 100 mm 150 mm thick to reduce heat gain from intense solar radiation. So that is also added in the roof. Then orientation and street design. Streets are oriented to minimize direct sun exposure and channel prevailing winds, improving thermal comfort. So in these kind of buildings, in these kind of buildings, so the building orientation is done such a way that it minimizes direct sun exposure in these buildings. So the design strategies for composite climate, wherein the temperature is very extreme during summer as well as during winter. So the building must perform under temperature which ranges from at least 5 degrees Celsius in winter to 40 to 45 degrees Celsius in summer. So like Nagpur, Delhi, and also some other parts of India. So these are some of the major example of cities which experience composite climate. Adjustable openings, like openings allowing cross ventilation which can reduce indoor temperature, that is preferred. Courtyard houses, so courtyards are also preferred in these climatic region because it provides ventilation in summer and allows sunlight during winter. Verandas and shaded spaces. Verandas act as buffer zones, reducing heat gain and providing outdoor living spaces. So these verandas are very useful in different climatic region based on how it is actually used. In case of cold and cloudy and cold and sunny, we can use these verandas as solariums, and then in warm and humid and in composite climate we can use it as a buffer space, also in hot and dry, so that the direct sunlight is not entering the habitable spaces. Further, the use of thermal mass material like brick walls of at least 230 to 350 mm thick helps in stabilizing window temperature fluctuation. So, thick materials are suggested to be used in composite climate. The building orientation has to be such that it ensures winter sunlight and protection from harsh summer sun. So, mostly east-west axis is not preferred over here. The building has to be designed in north south axis. So, with that the orientation can be well designed. So, the case study of these kind of buildings are the traditional havelis that we have seen in Chandni Chowk. So, the climate context for Delhi is for summers it is somewhere between 40 to 45 the extreme temperature, and in winters it reduces to 5 to 8 degrees Celsius. The urban form that mostly is preferred is dense and compact, so it reduces solar exposure and creates shaded streets. So, that is also why it is preferred is because comparatively if you see the number of days which is affected by extreme summer with the extreme winter, the summer actually outweighs the winter. So, winter in these regions are mostly for 2 to 3 weeks, not more than that, but the summer season in these regions are for more than 2 months. So, there are peak months like May and June are the extreme seasons in these climatic regions somewhere, but the summer actually starts very early from March, April and extends till May or early June, and then only with the arrival of monsoon the temperature reduces in these regions. Courtyard planning is preferred because of this region that it allows the hot air to pass easily and provide some cooling space during summers, and also during winters it allows sunlight to penetrate the structure. Building orientation is designed in such a way that prevailing wind direction the openings are designed. Openings, small to medium windows plus jalis are added in these features. Shaded spaces like verandas, balconies are added. Materials that are commonly used are stone and lime plastered walls. Ventilation strategies like courtyards are very much common, plus openings enable cross ventilation in these spaces. Overall, the vegetation that they added is generally added are limited, but internal courtyards and trees create cooler microclimates in this particular region. Indoor spaces remain 4 to 6 degree cooler in summer and retain warmth in winter due to thermal mass. So, the thermal mass of the material has to be ensured in with such material as given above, like stone and lime plastered wall has to be used. For warm and humid climatic region, the design strategies are like lightweight construction materials like bamboo, timber and thatch are used as they do not store heat for long. Large openings for cross ventilation is added. Raised plinths or stilt houses are also added. Steep sloping roofs, wide roof overhangs are suggested, and then vegetation and landscaping is also added over here. For the example of these kind of houses are Nalukettu courtyard planning that is seen in Kollam, Kerala. So, the central courtyard enhances ventilation and daylight, improving indoor comfort. So, these are typical Kerala style houses. So, sloping tile roofs, because there is too much of rainfall in this region. So, you have to go for sloping roof which doesn't which allows quick like flow of water from top of the roof to the bottom very easily. Sloping tile roofs of inclination around 30 degree to 40 degree is preferred with clay tiles. Then timber construction, timber walls and frames reduces heat storage and perform well in humid conditions. Large openings, as I was explaining you before, these are large overhangs that are added in the design, and it protects the walls from direct exposure of the sun and rain. Also, there are buffer places like verandas that are they are designed here. So, these are buffer spaces that are there all along the houses. Then laterite stone blocks that are added which with raised plinths prevent moisture ingress and flooding in the in these particular regions. So, vegetation around the houses that are preferred are coconut trees and greenery creates shaded microclimate, reducing ambient temperature by 2 to 3 degree Celsius. So overall, the thermal comfort strategies in vernacular architecture in all these 6 climatic region, we have seen that thermal mass utilization is one of the inherent property of vernacular architecture. So thick walls depending or thin walls depending on the climatic region, it is preferred. So thick walls are preferred in regions where you want to maximize heat gain or minimize heat gain, and thin walls are used where you want the continuous cross ventilation, for example in warm and humid or in moderate climatic region. The natural ventilation is also one of the factor where cross ventilation can increase air movement by 0.5 to 1.5 meter per second, thereby improving the thermal comfort of the structure. Then the shading devices like verandas, jalis and overhangs reduces the direct solar radiation. So that also is an important factor that has to be considered, along with the courtyard microclimate. So courtyards reduce indoor temperature by 2 to 4 degrees Celsius through shading and airflow. So these are also one of the important factors for enhancing thermal comfort in vernacular buildings. Along with that, roof insulation techniques, so either it is mud or thatch roof layers of 100 to 150 mm thick, it depends where you are going to use it. So based on that, the design has to be altered. Then evaporative cooling like the presence of water bodies and vegetations can lower the ambient temperature by 2 to 3 degrees Celsius. So based on the climatic region, for example if it is hot and dry climatic region, so there you have to promote evaporative cooling, because these promote the air to cool down, but you can't use this in warm and humid and cold and cloudy climatic region, because there is already humidity too much in the air in cold and cloudy climatic region. So accordingly the materials have to be used and have to be preferred in design of the buildings in these different climatic regions. So overall the lessons for modern low cost housing is that that from all this vernacular architecture we have seen that how we can integrate the passive design in the building. So these modern buildings can also work around ventilation, shading and orientation, so that they are designed as per the climatic region. So the regions which require high amount of solar exposure, so there you can maximize solar heat gain, but the regions which require minimal amount of solar heat gain, so there the openings and all these ventilation and shading strategies have to be designed accordingly. So use of local materials, so these are already as per the different availability of material in different climatic zone, so accordingly it has to be used for different construction. So energy efficient design, like it reduces the dependency on active means of cooling or heating of spaces. So the dependency on passive strategies has to be maximized in the design. So community participation, ultimately since it is entirely based on local traditional knowledge often known as vernacular architecture, so the community participation is also increased in such kind of design practices. Sustainable housing development, where we focus more on passive design features, so ultimately sustainability of these kind of projects are improved because we minimize the use of materials which has high embodied energy or which has high carbon emission. So overall, using these strategies, the cost of the construction is minimized and the affordability is enhanced in this in the construction. So to conclude, it can be said that the vernacular architecture has a strong relevance to the local climate and environment, because these are the two factors which determine the architectural style that has to be followed in all different regions of India and also in other places. Climate responsive design has improved the thermal comfort and it reduces the energy use in the structure. So these are basically dependent on passive design features. So these passive design features, if it is used well in the design of the construction, it minimizes the cost of the construction. Also it improves thermal comfort and reduces the dependency on active means of cooling or heating of spaces. So also the traditional materials and techniques are very economical and sustainable in use. So that is also the reason why vernacular architecture has to be promoted and actively used in design. Further, the passive strategies like courtyards, shading and ventilation are very important, and they have to be used as much as possible in the design, as it reduces the cost of construction. So, combining these different principles with modern construction technology, it can further promote the sustainable development approach that has been following in the construction industry. So, these are some activities that are suggested that you can complete after this lecture is over, and if there is any difficulty in solving this, you can put up in discussion forum where we will try to answer the doubts and questions. So, in our next presentation, we will focus on earth as a building material, where we will understand how earth, the different forms of earth or the different construction techniques evolved through earth as a building material can be used in low cost construction and maximize the affordability of construction. So, with this, I would like to conclude my lecture and also give you a glimpse of some of the reading materials that you can refer, and you can refer more on the topics that are covered in this presentation. So, thank you for your patience listening, and I hope that the topics that were covered in this entire unit, starting from the different low cost material and techniques, and with the vernacular architecture and climate responsive design features, were very helpful for you to understand how these features can maximize affordability of the construction and also minimize the cost of construction. So, thank you for your patience listening.